You tell me the scale factor now. All right, that's what I want to do first today. I'll give you a point, and it's dilated point. All right, so R is the dilated point, A is the pre-image, and look where it's centered around. This is huge for us, huge. It's centered at the origin, which means I can multiply if I wanted to. Determine the scale factor of each. So let's look at number 1, 3, 4 to 9, 2. 3, 4 to 9, 2. And again, you're doing it around the origin, so you know you're multiplying your original coordinate by a number. So as I go from 3 to 9 and 4 to 12. And again, I can do this because it's around the origin. I don't have to go slope and determine the slope. So 3 to 9, 4 to 12. What are we multiplying by here? 5? 5, 3. So my scale factor. 3. Yep. All right, sometimes it's not going to be that easy to figure it out, and I'll give you a little trick. 9 to 6, 12 to 8. That's not a number I know off the top of my head, right? 9 times what gives me 6? 12 times what gives me 8? But hey, if it's not something as easy as number 1 was, where you could just say, oh, that's 3, you can set up a quick equation. 9 times whatever my scale factor is, I'll just throw an X in there, is going to give me what on the other side? 9 times whatever the scale factor is should give me, what's 9 correspond to on the other side? Just keep calling it. 4? 6. There you go, guys. So if it's not obvious, set up a quick equation. Or I could have done 12 times X equals 8. And there you go. Divide both sides by 9. X is equal to 6/9. What's 6/9 reduced? Because I like the reduced version. 2/3. So 2/3. So there's your scale factor, 2/3. And then how about 3? I'm going from -2 to -10, -3 to -5. This looks, be careful on your signs though. It looks obvious, but be careful with your signs. Scale factor here, what am I multiplying by both times? 3. 12. So I'm going 2 times this gives me -10. 3 times that, -3 times that gives me -5. +5. Yep, got to be positive. That's why I say watch out for your signs. All right, any issues with the points? All right, let's go to a diagram now. B, here's the important part. B is the image of A, everyone. B is the image of A. After a dilation through the origin, you guys help me find the scale factors now. B is the image of A. So am I getting smaller or bigger here in figure number 1? B is the image. Smaller or bigger? Smaller, right? So your scale factor you give me should be less than 1. Should be between 0 and 1. Should be bigger than 1 because that's an enlargement. This is a reduction. All right, any suggestions on how I can find the scale factor? Go ahead, Rick.
Find like a point on that.
That's what I would do because again, hey, look where I'm centered around. Centered around the origin, right? So what Rachel says is, all right, just take a point here. So I don't know, let's take this point right here, which is -1, -1. Find its corresponding point, which would be right here, and that's what? 1, 2, 3, -3, -3, and what am I multiplying by here? And be careful though. You guys told me you're getting smaller. So you can't have a number bigger than 1. All right, you can't have a number bigger than 1 here. So I know some of you probably want to tell me 3, but 3 won't cut it because 3 would be an enlargement. This is a reduction going back from B. Again, hey guys, set up an equation. Ready? -1. I'm sorry, I'm going the other way, right? I got to start with A. -3 times what gives me -1? Okay. Keep that in mind that when you are shrinking, you need your scale factor to be less than 1. Divide both sides by -3. What's my scale factor here in number 4? 6, 1/3. Yep. Again, you put 3. You guys are telling me it's being blown up, which it's not. A to B is not being blown up. All right, next up, number 5. Now it's enlarging. So now you should be giving me a scale factor back that is bigger than 1. All right, so go ahead, see if you can find it here. I, again, pick 2 corresponding points. What do you got to multiply by? And make sure it's bigger than 1 when you tell me. Did you find that scale factor? Bigger than 1, bigger than 1. 1, Anna, did you find it?
2.5.
2.5, yep. I'll put 5 halves, 2.5, also great. Any issues on how we got 2.5? Want to see that? Pick 2 points. What do I multiply by? And you ready for 6? A to B. Getting smaller now. Getting smaller. So you should have a scale factor for me that's less than 1, but bigger than 0. And what do you got here for my scale factor? Getting smaller. Getting smaller. 13. Buck. 1 over 9. Buck. Yeah. 1/3. Got it. So just watch if you're getting smaller or bigger. Any issues finding them? We're pretty solid there now, finding the scale factor. And look, honestly, guys, am I ever going to have you find a scale factor that's not around the origin? No. Okay, I won't do that to you. All right, here we go. One more before we pick up the compass. I got A, B, C, and now I got A prime, B prime to C prime. Describe the transformation. Well, do we see a change in size, right? So we know it's got to be a dilation, translation, reflection, rotation, don't change size. So we know it's got to be a dilation. But just like this whole unit here, I just can't write this. A dilation won't cut it. You got to tell me more. What's the dilation with the scale factor of? Centered at here. Okay, well, are we getting bigger or smaller first? Bigger or smaller? Okay. 9, bigger or smaller? Bigger. So you better tell me a dilation with a scale factor. And that scale factor you're about to write down better be bigger than 1. Because this is an enlargement. Better be bigger than 1. Go ahead and find it. And again, you can assume it's around the origin here. But just make sure your scale factor works for at least 2 points. Okay, check 2 points. Make sure it works for at least 2 points so I know it's centered around the origin. Because if your scale factor works for 2 points, that means it's around the origin. Make sure it's bigger than 1. All right, what's your scale factor for me? Two.
2.5.
2.5. So a dilation with a scale factor 2.5, centered at the origin. Got to tell me where it's centered around. Centered at the origin. All right, now explain why. What was that? What's that symbol in between again? Remind me of that unit. 6. What's that symbol in between? Similar. Why are the triangles similar? Well, we know how to show them congruent, right? Rigid motions, but these aren't rigid motions. We just did a dilation. So explain to me why they're similar. Ready? Dilations preserve. What's the only thing dilations preserve? And there you go, right? Not distance like the rigid motions do, just preserve angle measure. Dilations preserve angle measure. What are we putting? Thus, in conclusion, henceforth. So, therefore, all right, you got it. Therefore, triangle A prime, B prime, C prime is similar to triangle ABC. Okay? Because remember, two triangles to be similar, we just need their angles to be congruent. Just need their angles. Alrighty. Any questions finding the scale factor? Are you ready to dilate a figure using your compass now? All right, let's pick it up. Compass, straight edge. Let's do this. All right. Dilate triangle art with center O with scale factor 1/2. All right, let's talk first before we start just throwing down compass marks.
Oh,
good playtime. Is art going to get smaller or bigger? Smaller. Dilation's 1/2. Are points A, R, and T going to get further away from O or closer to O? Closer. Everyone agrees. A, R, and T should be getting closer to O because the scale factor is 1/2, meaning the triangle is going to get smaller. How much closer are they going to get to O? Halfway. Charlie, you pick which point you want to dilate first. R, you got it. So everyone connect R to O right now. Connect R to O with your straight edge. Okay, take your straight edge, connect R to O. Okay, right now by connecting them, you're showing me how far apart they are. And I want to cut that distance in half. I want to cut that distance in half, and that's where R prime will be. Cut it in half. Cut this, RO, in half. If we learned something in the past, how to cut a line segment in half? Yeah, we have. Let's get that compass out. We're going to cut this distance in half. Put your compass point on R or O, doesn't matter. Remember this one? Open up your compass. More than half the length. We're going to make a decent size arc here. About a half circle size arc. Back to using our buddies. Come on over. Leave your compass open the same opening. Come on over to the other end point and do that same half circle arc. Make sure it intersects twice. You should have 2 points of intersection on both arcs. Now, so your paper doesn't start looking crazy, when you take your straight edge right now and line it up, you don't need to draw that full line in. All right, I don't care about the perpendicular bisector. What I care about is where R prime is going to be. So all you guys need to do is line it up, line your straight edge up, and make a mark on RO where it crosses. And that's R prime. You moved it halfway closer. You cut the distance in half. All right, so you don't have all these lines flying around. Line up your straight edge through the both points of intersection, and then just make a little mark where it intersects RO, and that is R prime. Okay, that's R prime. And that's what we're going to do for the rest of the points. We're going to now, you choose. All right, you choose. You could go T or you can go A, whatever you prefer. Cut that line segment in half using your compass. And then make a marking where T prime and A prime should be. All right, so go ahead. You need a compass? Chan?
Oh no, yeah.
Okay, let's use it. What are you waiting for?
I don't really understand. What are we cutting 18 now?
No. You got, see how we just cut the distance from R to O?
Yeah.
Now we got to cut the distance from A to O. A's getting
A,
closer to O. T's getting closer to O. Okay? And then at the end, you should have a smaller triangle. Okay, so for this next one here, scale factor of 2 centered at B. B is not going anywhere, but ready? Point A and C, getting closer to B or further away? Further away, right? So I'm going to get a bigger triangle, but the only exception is B is not going to go anywhere. It's staying right there, so there's B prime. All right, now we know how to cut it in half now with our compass. Now how do I double the distance? How do I double this distance? Well, if you take your compass right now and open it up, I need to double that distance right now that my compass is open, doubling that distance. And it's got to get further away. Can't go on the other side of B. It's got to get further away from A. All right, so everyone's got that distance from B to A. All right, take your compass off now. Grab your straight edge now. Grab your straight edge and extend. Extend side BA. All right, extend side BA. And maybe you know what's happening here now. Extend side BA. All right, now go back to your compass. Right, you had the distance from B to A, and I want to double it. 2. I want to double it. So now I'm just going to take my compass, go up to A, and make a little mark on my extended line. I just doubled the distance from B to A. And there's A prime. And now I'm going to do the same thing from B to C. Make sure you're not ever on the opposite side of the point we're dilating around. Make sure you stay on the same side. B and C on the same side. Open up your compass the length of BC. Open it up to BC. There's C prime. Bless you. And then let's answer the question, is this image similar to the original? Is it similar? Yes, no, maybe, similar. 4, similar.
Yes.
Yep, we just went over this, right? Yes, because dilations do what, everybody? Dilations. 7, preserve. 13, preserve. There you go. Because dilations preserve angle measure. That is awful spelling. Hopefully nobody saw that. Preserve angle measure. Thus, triangle ABC similar to A prime, B prime, C prime. All right, questions? Constructions or finding the scale factor? All right, go ahead. You guys are rolling along now. We got one more day of this unit on Monday. Tomorrow, no school. So let's get this done here.